Here are the solutions to one of the problems from section 7.2. Here we're being asked about the X-bar distribution, the distribution of the sample means when we're pulling stuff from a population that has some given information about it. So we have that the population distribution for the number of years of education has a mean of 14.6 and a standard deviation of 3.2. So in our symbols, we would call that a mu equals 14.6 and sigma equals 3.2. Those are our symbols for population mean and population standard deviation. That's unusual to know that, and you've seen in a lot of problems that we work with these things hypothetically, so it shouldn't bother us too much that we given a distribution where we're supposed to pretend like we know the exact population parameters. Anyway, so we can tell that's what it is because it says population here. So in other words, if it were possible to send out a survey to every single self-employed individuals in this region, what we should think about is what would we ask them? Like we would ask them for the number of years of education, and they would all write that down, and we would get all those answers back. Each one's a number. And we would take the average of those numbers, and it would be 14.6, and the standard deviation of those numbers would be 3.2. So hypothetically, that's what mu and sigma represent, if we could actually ask everybody. So now let's try to put all the rest of these problems into context. The first question says, what's the random variable? And so we've learned that the random variable is, the variable is really just the question from the survey. So the question that would be asked of everyone, if we could ask it, was how many years of education? So that's this answer. Okay, and we'd be asking that among all self-employed individuals in a certain region. So that's our population, and that's the question that we'd be asking them. So then it asks us for some information about the sampling distribution of various sizes. So remember, when we have the sampling distribution should also be a normal curve. The center of the sampling distribution ought to match the center of the population distribution. So in other words, if I go off and ask a bunch of people their ages and take those averages, I shouldn't expect that on average to be any different than the 14.6 that we believe is true in the entire population. So the number of years of education. So 14.6 should be the center of the sampling distribution regardless of how big the sample size is. And so in all of these questions you'll notice that it says what's the mean, what's the mean of the sampling distribution, 14.6, right? It's always 14.6. So the mean of the sampling distribution should match the mean of the population distribution. The thing that changes in the X-bar distribution is how varied we expect these answers to be. So in other words, when we draw our normal distribution, we typically put 3 tick marks on either side. The tick marks, the width between the tick marks is what we call standard error. So standard error is this distance between tick marks. The formula for standard error is sigma over the square root of n. That's a formula that you'll be given on the exam. So that involves both the spread of the population numbers and also the sample size. So in this case, sigma is given to us to be 3.2. And here in the first question it says size 64, so sample of size 64. If we do that, you get 0.4. So the standard deviation of the X-bar distribution is 0.4. So that's how far apart these tick marks are. So this would be 15.0, this would be 14.2, right? So we could label the sampling distribution from knowing that. All that changes when you increase the sample size, so in this question it asks us to blow the sample size up even bigger, well that's just a different value of n. And so as you make the sample size go from 64 to 256, the standard error is going to go down, and so the distance between the tick marks is going to be smaller. So a picture of the X-bar distribution for a 256 person sample is still going to be centered at 14.6, the population mean. We're still going to put 3 tick marks in each direction, but now the standard error, if we figure it out with 256 for n, is going to be 0.2. So we're going to have 14.8, 14.4, those are going to be our tick marks in this X-bar distribution. So what that means is that we expect that if we go off and ask 256 people their number of years of education and take the average of those 256, that the numbers we get for the averages are going to be very tightly clustered around 14.6. They're going to range from, maybe 14 up to 15. They're not going to get further away than that because most of them are going to fit in here. If we had only asked 64 people and calculated the average answer to this question for the 64 people and put those X-bars together, we'll get a wider distribution. It wouldn't surprise us at all to have an X-bar that's, say, bigger than 15 if we only ask 64 people. If we ask 256 people, it would be very surprising to get an X-bar value of, say, of 15 or higher. It would have to be way out here. So the larger the sample size, the less variation, the less variability there is in the sample statistic X-bar. That's what's being reflected here. Notice that in any of these questions, if the original is normally distributed, or this distribution, we could answer probability questions because we know how to use our calculator to find, say, the area under this curve from like 15.0 and bigger. We know how to do that. We could answer the same question here. What's the probability on this curve of getting an X-bar that's 15.0 or bigger? We should see that the probability of having 15.0 or bigger in this curve is much bigger than the probability of getting 15.0 or bigger in this curve. So we should be able to answer questions like that on these distributions because we know how to use the normal CDF function on our calculator.